We are back in the user interface of ABES geoCon, and we are about to cast the third segment in this casting sequence. The third segment being this segment here. For the first time in this series, we will introduce a casting error, and we will check how the software compensates for this casting error in subsequent segments. As we already know, we press next. The program comes up with our setting out data for the matchcast segment here and for the conjugate segment down here. The segment has been aligned to a horizontal surface and centered in the casting cell, and we are now prepared to accept the data. The people in the casting yard can go away, cast the segment, and when they come back, or when the surveyor comes back to us with the survey data of our control points, we can press next and we can input the control point measurements in these boxes here. If everything was perfect, the deviations would be 0. As the viewer will note, we have switched back to an input mode where we record deviations from the intended positions. However, real life is rarely perfect, and if we mimic real life in this situation, the surveyor may have come back with numbers looking a little bit like this. They're all deviations in the order of up to 5 millimeters, so that's already quite a lot. We have the deviations up here for the control points in the matchcast segment. These deviations are simply recorded as these are the locations of the control point markers that have been set into the concrete, and they have no influence on the actual shape of the segment. This is different with the measurements down here. These are the control points in the conjugate segment, and the conjugate segment has been cast earlier and in theory was moved into the setting out position before casting of the new segment. If the control points now deviate from the setting out data, this is an indication that the shape of the new segment will look somewhat different to what we intended it to look. So let's assume these random numbers in fact are our measurement data for this casting process, and let's continue. If we press accept, the program will issue this warning here telling us that our alert levels, or tolerances if you like, have been exceeded. We get a report for the control point in the matchcast segment where we have a maximum deviation of 6 millimeters and the mean deviation of 5.5 millimeters, and if we want to know the details, we can get them by clicking on the details button, and here we get our deviations for every control point in this segment. Same for the conjugate segment, and if we want a overview over our alert levels, we can get them here. So this window tells us which alert levels have been exceeded and which ones have been kept. If the numbers are too big, that's sometimes an indication that there is a typing error, and we might want to go back and check our inputs. But if this is the proper data that comes from the surveyor, we can proceed and press OK. We can visualize that casting error best by switching off the casting curve and the setting out geometry and leaving only the S-cast geometry visible. And by sliding this slider up and down, we can get a visualization of the casting error, of course with a substantial exaggeration, but we can see the error that we have just introduced. Getting back to the alert levels that we saw in the warning window, I'd like to point to the options dialog and point out the alert levels that can be set in this dialog. Most interestingly would be the alert levels for the conjugate segment, which can be set for X, Y, and Z, and for the mean values, and same for the matchcast segment. So we have a casting error now, and it is geocon's duty to guide us back as closely as possible to the intended shape of our bridge. Since there are translationary and rotationally errors present in this casting error that we have introduced, it will take 2 segments to rectify the issue. And these segments, incidentally, the next 2 segments will only compensate the error if they are cast perfectly in the sense of the setting out data that geoCon will give us. If we introduce additional errors, then of course geoCon will keep track of these additional errors, and geoCon will always try to compensate for the accumulated errors that occur throughout the casting sequence. This view explains the error compensation a little bit further. This is the segment where we conducted our casting error, and these 2 segments have been cast perfectly afterwards. The first segment brings the segment centerline back to the intended alignment, and in doing so, and in keeping of course the right angles for the bulkhead on both sides, the program arrives at a joint that's still an angular difference to what we originally intended. The next segment will also bring the joint back into the intended alignment and correct the remaining angular error, casting error of course. This is of course always assuming that we can cast 2 subsequent perfect segments without any casting error. I would like to get back to one more aspect of the error compensation, and in doing so we are about to cast the next segment. So let's assume for a starting point that everything was perfect again and the next segment in our sequence was cast perfectly. Now let's concentrate on the conjugate segment, which was already cast before in concrete. The markers have been set and hardened into this concrete. So this is a rigid body, and we know from our previous survey the relative position and the absolute positions of these control point markers. If we have casting errors, one would assume that this body with these, or this segment with these set control points, would move as a rigid body. However, we have 6 control points and we have measurements for all 6 control points, and it's very rare that these measurements reflect the exact rigid body movement of our segment. It's more likely that the measurements reflect a slight difference with when compared to the model of the segment that we have already stored. So let's assume that, to illustrate this point, let's assume that all measurements are perfect except one measurement, and that's out by 100 millimeters. So this is not a rigid body movement anymore. All the control points are in their locations except for this one control point where the surveyor tells us it has moved sideways by 100 millimeters. There is a conundrum for the program because now it is the data, the geometrical data, is overdefined. The program cannot perform a rigid body movement of the segment into the measured positions because only one control point in only one degree of freedom is different. So what the program does is it finds the closest fit. It fits the stored rigid body data of our existing segment as closely as possible to the measurement data. So let's accept this. Of course, our displacement levels are exceeded, and let's have another look at the details for our conjugate segment. And here we see that we had 100 millimeters here, but that's sort of shrunk to a little bit less and has been redistributed to other degrees of freedom, and that's the fitting algorithm that has occurred. The program has of course weighted the other data greater, but there has been a fit and a slight readjustment compared to the measurement data. In our case, we've only had this effect in 1 degree of freedom, one coordinate component, but in reality this will happen with every survey because slight differences to the rigid body movement will always occur.